Hey everyone, I'm Nima from Labs, joined here by Kais and Ishmael from Lagrange, as well as Mikhail from Gearbox. Recently, there was a collaboration announced with these folks for how Gearbox can use the capabilities offered by the Lagrange Coprocessor, and we're super excited to dive into this. Without further ado, I will pass it over to Mikhail to give us some context as to what Gearbox is and how this integration works.
Hi everyone, thanks Nemo for introduction. Gearbox is a lending protocol and we built something more interesting than usual lending. In Gearbox, you can really consider as a next step account abstraction when lending embedded in your wallet and you can easily get money or like on-chain credit when you need it. It works like a magic and you easily can get something like leverage for credit when it's needed. And of course, Gearbox, we work since 2021, has different version, now finalizing the third one. And we faced with a very interesting topic to discuss and make a partnership with Lagrange. Because previously, before AVSs and all the stuff, it was not possible to get into history and track balances from the credit account side. So today we will talk a very good solution how to bring new UX and better possibilities all together from the whole stack, like DeFi protocol, ZK coprocessor, and UX for the end user.
Wonderful. Thank you so much for being here, Mikhail. Thank you so much for hosting Nima. My name's Ismail. I'm one of the co-founders of Lagrange. We are one of the leading ZK coprocessors right now. We focus on a very specific type of SQL-based coprocessing that can scale computation in a very meaningful and expressive way over on-chain data for applications ranging from DeFi to SocialFi to consumer to NFTs. I'm joined here by Kais, one of our blockchain and DevOps engineers on our team. And so, yeah, very excited to be here and walk through some ways that the integration and the partnership work, as well as show some code and some actual a demo of how Gearbox and Lagrange are working together.
Awesome. So who would be best to start, to kick off what the actual use case here is in terms of like the Gearbox capabilities, and then maybe highlight what this integration actually means?
Yes, I can start, and I hope Ismail could continue from more stuff related to the ZK processor, because as you know, it's a very hype topic for users to make a better UX. We talk a lot of chain abstraction, account abstraction to deliver the best UX and make the things not so painful. And in Gearbox, because we deployed on multiple chain, users faced with the problem how to claim rewards. Literally, you can go to mainnet and claim there. Then if you have multiple rewards, it becomes much more messy because from developer side, we should deploy maybe 2 or 3 MasterChef contracts or create a Merkle tree. So you go to one LM contracts like MasterChef to claim rewards, then you go to Merkle, then you switch to another network and claim rewards on Optimism and then on Arbitrum. So it was extremely messy. And why it happened? Because as we know, the better way to provide rewards is a MasterChef contract, which was designed by Synthetics. Pretty good math formula. Works fine, but has some limitation. And in this case, we decided what could happen if we can use the ZK processor to track user balances and compute all this stuff to make a one-click experience to get all rewards across multiple chains. And then Ismail could talk a little bit more how it could be done technically, and then we can wrap up how to deliver the whole experience to end user and how it could be different.
That's a great segue, Mikhail. So, I think one of the areas that we've most enjoyed collaborating with Gearbox about is really kind of thinking through how the next generation of on-chain DeFi standards can leverage primitives like ZK coprocessing to their foundation. So when we look at something like a MasterChef contract or maybe a 1-inch farming pool, it's fantastic logic for issuing a reward based on continually holding an asset for a duration. For example, I provide liquidity into Diesel ETH and I get a reward proportionate to the amount of time that I provided that liquidity. Well, what if I want multiple campaigns? What if I want to incentivize something cross-chain? What if I want to be able to claim based on my multi-chain position? All of these cases start breaking the core logic of what you can actually do in Solidity. With co-processing, you remove those limitations. You can directly access historical on-chain data, and you can directly structure computation over it. So for example, you can run a query that says, how much ETH has Ismail deposited between block 1000 and block 10,000? And I can find the average, I can find the proportion per block, I can take the integral, and I can determine how much of a continually issued reward I am eligible for. And this is taking, a very fundamental primitive in on-chain incentive construction, and it's bringing it forward to the modern infrastructure that we now have available to us. And this is not something that I myself would have identified. So very thankful that Mikhail was able to see this and be able to see, very much where these new primitives can be fundamentally accretive to what it is to have capital efficient on-chain DeFi.
Yeah, it's totally correct. And one more point here, that if we use a smart contract side, so previously we consider smart contracts is only the way how we can build backends. But literally at this case, all developer who has some experience of development know these very scary words as load and as store. Each time when you get data from the disk of mining machine, you should pay a lot of gas. So making like a history movement back and track all balances from the whole time, or at least check when they differs, could take a lot of computational resources and gas. And consider this from another point. If you want to deliver the best, we should not ask a user to pay an amount of money comparable with the reward, because it requires like millions of gas. It's why I believe the next generation of application could definitely use a lot of different things like helpers to build a more system related and deployed on multiple systems, not only smart contracts on execution layer. It could be like things like ZK coprocessor, and of course some rollups which could also help the whole experience of end user. And these gas savings comparable with new UX could really be next part of growing in whole industry, because people are really tired about current UX. They want to more, better, and faster and cheaper in terms of gas savings. And Ismail, what do you think? How we can deliver totally new experience and better UX for next billion users?
Yeah. So you had a very great tweet recently, Mikhail, that I thought articulated it very well. And that tweet was talking about a microservices architecture for this next generation of DeFi applications. And what I think is so prescient about that is it articulates, in my view, the embodiment of what happens when you kind of combine all of these different infrastructure primitives that the industry has spent the better part of 2 years building. All the way from rollups for high throughput stateful compute to co-processors for asynchronous stateless compute to AI and other types of middleware that access different type of core services in your DApp. And with all of that combined, you're able to kind of leverage all of this asynchronous communication between different execution components that in totality lets you build things you couldn't otherwise do. You can have a high throughput chain for a lot of your core application functioning with reward issuance and reward claiming back on L1 through co-processing. You can have AI to determine protocol and risk parameters. There's just such a rich there's such a rich design space of the things you can start building when you start looking at all these different primitives in totality. And I think the work that we're doing together with co-processing in the lens of farming pools and MasterChef contracts is really kind of the first step that we're seeing in DeFi of new standards being established that fundamentally use novel infrastructure at their core. Almost every DeFi standard, I think every DeFi standard that we've currently used or currently adopted are all solely using just native execution environments like the EVM. This is the first one that combines the EVM with an asynchronous off-chain compute component. So with that said, I think it would be wonderful to walk through the code and look at some of the example, look at the example of exactly kind of what this looks like from a Solidity standpoint.
Awesome.
Yep, let's do it.
Wonderful. Just pause. How's the screen look?
Yep, looks good.
All right. So this is a example contract of what it would look like to have an ERC20 reward distributor based on ZK co-processing. Very much the farming pool MasterChef standards that Mikhail was talking about. Much of the work here was done by Mikhail and his team, Ivan on his team as well, who wrote a lot of the core logic, which was enhanced on a little bit by a few members of the Lagrange team, like Kais here as well as Nicola and a few other people. So when you're dealing with a ZK coprocessor, it's important to kind of consider a few basic constants that your contract needs to instantiate. What we start with is something called a query hash, which is a commitment to the off-chain computation that you want to execute. In this case, a SQL query that averages balance across a range of blocks. What's the point of the functional commitment that we have here? Well, it's that you can specify what computation you want to run when you request it from the off-chain prover network. From there, we have a reward rate, which specifies the amount of incentives to be issued per block based on liquidity provisioning or liquidity depositing. You can think of this as something within Diesel ETH or really in any kind of liquidity incentive, liquidity mining campaign. We also have a struct here that we call expected row result. This is an interesting component of Lagrange's coprocessor particularly. With Lagrange's coprocessor, it's SQL based, which means that the data you get back is in row column format. As such, you need to be able to specify in Solidity what the structure of the columns that you get back are, right? So if you get back a very big list of data that's encoded as a byte string, we need to parse that into an object that you can then interact with in Solidity. And that's where the struct that we have for row values come in. And then we have a number of other variables here that allow us to kind of control how reward claiming and reward issuance is done in the incentives contract to prevent double claiming, as well as to determine what contract we're going to be running these queries over. And so the core of this contract is the initiate claim function. This is how, when a user wants to claim the reward balance, the function they call. And so the initiate claim takes a number of parameters, including the address of the holder, the query hash that we talked about before, the functional commitment to what the query is, as well as some call data placeholders. You can think of these like placeholders in SQL, right? Variables that you'll fill in at runtime. And then a start block and an end block. The range of blocks you want to run this query over, in this case, an average of a user's balance. We do a couple checks to make sure that the query is well formed, and then we load the correct data that the user specified into the placeholder struct, or the placeholder array. From there, we're able to make an asynchronous call to our query manager contract that emits an event and requests a proof to be generated by Lagrange's prover network. And so here, for example, you can see that we have a last claimed mapping where we determine the last block that a user has claimed the reward at, and we record every time they claim the reward to prevent them from double claiming over an interval. We also specify a payment to the Lagrange prover network registry to ensure that the callback that's done is properly funded and that the network is properly remunerated for the compute that's required for the proof. Now, as we talked about a little bit before, a ZK coprocessor is an asynchronous development paradigm. What that means is a function call to a ZK coprocessor or a request for a proof from a coprocessor is not synchronous. So if you make that request at block B, you expect to get your reward back, or you expect to get your result back at block B plus K at some future point. As such, you have to instantiate a callback function, a function that when that proof comes back and the result is available, will be called within your contract. In this case, we inherit the interface to Lagrange's process callback interface. And so here we receive back a request ID as well as a query output. The query output is decoded so that we can map that into the row mapping that we've talked, the row struct that we've talked about before. As such, we can access the interval value, which is what Gearbox has named their variable for that column. And the interval value is how we determine the reward that a user should be entitled to per block. We divide that by the total supply to determine the amount of rewards that user is entitled to based on the proportionate amount of the supply. And then we multiply that by the reward rate and divide it by a precision multiplier to get to an even number to distribute our reward to. After that, we mint, in this case, new tokens that we distribute to that user. So throughout the whole flow, to summarize, a user deposits liquidity, they wait a period of blocks. When they want to claim that liquidity, they initiate a claim. That claim records all the information about that claim. Then it requests an off-chain proof to determine the amount of liquidity they provided over some interval. That proof comes back, and then the reward logic runs to issue that user a set of new tokens as their reward for providing that liquidity. So put simply, it's the MasterChef standard, it's the farming pool standard, but embodied in a more capital efficient and well-structured way through using ZK coprocessing as a primitive. Now, I'd love to get any kind of take from Mikhail on this over any other points I might have not properly covered in kind of the contract flow here.
I think so. Literally, there are a few things which we should take into account because previously we have a synchrony paradigm. And in this case, it's a little bit new stuff when you start building things on top of it. Because just imagine, in normal ETH node, you have a simulate call when you can get result as execution of any transaction. And here, it would be different because the transaction is just send a request to the key coprocessor, and you could not immediately the answer. And the problem that you should also talk the users and end users that the tokens will be transferred something in the future. I think maybe why we also so interested in this experience for Gearbox, because users somehow also learned this and experience from using intents. In intents, for example, if you go to 1inch or cow swap, you make a limit order, and then it's not also fulfilled immediately like MMM. The same logic here. You ask for claim, you wait how many seconds you need to get a request on average today, Ismail?
So if you want to query over 1 million storage slots, so maybe 1 million blocks in this case, or 500,000 blocks, be about 2 minutes.
Okay, so and literally you can get these tokens pretty soon. So at this case, when you think about adding some stuff on I don't know, like end user application, we should also provide some event generation when callback is executed to immediately notify the user how now the tokens are transferred and everything is done. But literally, if you compare this solution with other stuff, it's just to compute a numerical tree or is to go across a multiple contract, it seems that the gas price should be lower because we do not consume gas, especially on expensive networks like mainnet. Yeah, so it's still much more expensive than use Lagrange or other coprocessor, I believe so. Yeah, so or IVS solution. I am not only mentioned for this case, but for the global family of eigenlayer AVSs here. And I think we should definitely, as developers, explain end users how it works, why they should wait a little bit, because it's totally fine when we have something like Web2 experience. When you send a request, for example, you search for flights via search machine, etc., and we should wait when the system compute any stuff. The same things for intents, and here, like another example how blockchain system could work. And of course, when we improve the old technologies, it will be faster and better and easier for end users. So pretty good to have it here. And I think now we should not focus a lot on these gas consumptions and can focus on really UX.
I think that's very well put. Now, segueing from UX, I think this would be a great time for Kais to show a demo on
Awesome.
the experience here. But before we do that, Nima, any comments you want to make from the Eigen side or from kind of the developer flow side here?
I guess not in particular. Yeah, you guys both covered the grounds, I think, fairly well. I'm just excited that this is one of the first applications that really leverage the power of ZK coprocessing, as well as, you know, showcasing a real use case of how these two end up unlocking new behavior in a capital efficient and, you know, nice UX way. So, Kais, take it away.
Cool. Thank you, Nima, for hosting this, and yeah, thank you, Ismail, for the great presentation walkthrough for the contract. So yeah, like I think one thing is good to mention, that like the way this contract is able to actually launch this sort of query is that on the other side we are storing like data from the chain, and we structure it in a way off chain that allows us to make computations in a much efficient way to prove that data, like and the history of that. So yeah, so I'm gonna go through this process. I'm gonna share my screen, and that also is a good thing, because that allows, like, once you have it off chain, then you can just query it from whatever blockchain, use that data from any other chain. Yeah, which solves other problems like interoperability and yeah. Wait, infinity mirror dismiss. Okay, so the idea is that you say you go to like a ZK coprocessor, and then you need to make sure that your contract is pretty much allow listed, and then you're gonna specify a query. So if I go here, I want to create the query, which means I want to select something for a specific contract, and a contract here is defined as a table, because like this is taking it from chain state into SQL tables. So this is the kind of like transition that we do. So we can say, okay, I want to use this Gearbox table that I contract. Then I just set up the query. And then here it presents me with like an SQL, really like a, yeah, just like an SQL. This is where we're gonna define this thing. So here I'm gonna go ahead and what we're gonna do is just select for this demo, because what we want is pretty much show average on blocks. So we're gonna have, for a specific address, a holder of an ERC20 token, we're gonna average how much they have for a specific amount of blocks. So let's say a user holds, I don't know, 10% of the supply over 10 blocks. This is the amount they're gonna gather. The nice thing here, the nice addition here is that you don't have to do everything static. You can do placeholders. What I mean by this is I can set this, for example, like I can set it to a specific address here in this key, or I can just set $1. And then if I set $1, then anyone can at query time edit that as a SQL variable. So similarly here, instead of having this constant value of how much you want to reward your users, I can also just do $2, for example. Then you can also validate, just like a SQL tool, you validate the query, and then register. Register meaning you're going to add this on chain such that anyone can start using this this query and query the network of provers. So I'm gonna go ahead and register. Now it shows me a way how to like actually use that. So it's for developers. Yeah, nice. So now what this gives me is an actually like an SQL hash. So I can see the hash here. Like this is like a hash that they would use later on, as Ismail showed earlier, and that's like the identifier of that query. So yeah, once we have that, we can just go ahead and go to the contract and actually initiate a claim. So what I'm gonna do here, I am going to use this SQL query. And this is where here it says like query hash. To be able to say for this, I have this address within these two block range, like this block range. Please mint these tokens and send to that user. And the nice part here is that you don't need to be on the same chain. So the tokens, the ERC20 contract doesn't have to be on the same chain as we execute this query. And that makes the whole idea of being able to combine all this tokens from all these chains into whenever place we want in a very cheap manner. So yeah, so this is an amount that you would pay for the to launch the query, because when you launch the query, what happens on the back end is that there is a network of provers like Kraken, Coinbase, and all these guys. They are running machines on the back end, and these machines like do this generate these proofs, and then these proofs are combined into the Lagrange network, and then a callback is sent to the contract that is going to mint for that address the tokens. So this holder specifically holds half of the tokens for the sample contract. So if I check here, I have holders. Then you can see, not this one, it's another contract. Just a second, I need to get the ERC20 contract. Maybe Ismail, you could check the specific contract to show the holders, anyways, of the. But that user, that token, pretty much holds 50% of the supply. So here I put the query hash, and then here on the placeholder, this is the user. I'm going to choose here 10 blocks. So so this is the yeah, this is the starting block, this is the end block, and then I can run the transaction. Yeah. So if I view the transaction, okay, I can check the logs. So this is the contract, the client contract that we use now to do the query is gonna load another contract, which is the Lagrange contract, and this contract is gonna emit this log. So we see the start block that we chose, the end block, the gas fee, yeah, and then ID, the request ID. So what's happening now is pretty much the network is yeah, proving this this query. And here, this in our dashboarding, we see that we received this this query already, which usually takes about, yeah, it's already done, which is the 2 minutes that Ismail was referring to earlier. So now the network
Less than 2 minutes now.
Yeah, I think it's about 1 minute or something, but we have already the transaction ID, the transaction hash here. So if I actually go here and check for this contract, so I already see that 21 seconds ago, we received 500. So there's 500 tokens that have been minted. This is why you see here 00 to this holder that we chose. And the reason why we have 500 here is because we chose 10 blocks. And on every block, there is, on every block, there is 10, 100. So we have 50%
Yeah, every
of the supply.
every block we had a reward rate of 100. So we had 50% of the supply, so 50 per block times 10.
Yeah, so 500. Yeah. Yeah, I think that concludes the demo here. So thanks.
Awesome. So one of the things I wanted to highlight that I think was very unique about this demo was the developer ergonomics of being able to write your queries in SQL. That's something that's fundamentally unique to Lagrange and Lagrange's approach that I don't believe is otherwise available in the space, where you can think about your on-chain data as a relational table. The same thing in Dune or in Nansen or any type of big data or on-chain data analytics solution. But now you can structure that computation however you'd like, write SQL however you'd like, and verify the result in your contract on-chain. So one of the big iterations of Lagrange's product that went from our V0 to our V1 launch was the need to no longer handwrite circuits. You can simply write SQL, we can parse it, we can structure it, we can turn that into the relevant circuits with what is effectively a ZKVM for SQL. And then that can directly run and be verified on chain. We support a limited set of SQL operators now, but we have plans to support the entirety of SQL, as well as a paper on the theoretical basis of supporting the entirety of SQL that we should be releasing more of this year.
Great.
And now, I guess, Mikhail, I'd love to kind of get a take from you about how you sort of see this type of functionality being affected in DeFi, both in the context of Gearbox and then more broadly for both reward issuance or anything else that's top of mind for you.
I think, thanks for a question. And of course, congratulations with this great demo, because some part I've seen, especially when you go to internals first time, I believe we should also mention two very significant parts about the solution. The first part, because when we're talking about asynchronous communication, we should explain a little bit the warranty that we can get a callback execution. And I think it may be for Nima and for Ismail, for you, because people could start worrying, okay, this contract is just emit event, but nothing happens with blockchain data. And I think it's really great to highlight that it's all work as a contract and you can get result at any case. Yeah.
Yeah, I think that's very well put.
You know, maybe you want to add something related to AVS and SLA for kind of return things and follow the specific rules, design, and how the whole system could guarantee the same level of security like it exists on chain.
Yes, for Nima, for me. For Nima, yeah.
Yeah, I mean, I can just go over some of the properties, right? So the restaking gives you a very capital efficient way of getting these operators that are the backend mechanism for the prover network that is Lagrange's up and running, right? With the safety and liveness guarantees that we can now consider to actually productionize this kind of network, you can spin up such a network in a relatively short amount of time because, as Lagrange has been live for how many months now as well?
I think our prover
This
network
May.
went in production 4-6 months ago at this point.
Right.
Oh.
So being able to tap into these unprecedented levels of new UX, going from infra to actual products and use cases on top of, as Gearbox is doing, I think we'll see a lot more of that as we're just starting to get into the design space that AVSs can productionize. Since we're still really early, we're just seeing what the power of restaking does to how the compute power that validators across the entirety of the Ethereum network can bring to life, and how compute, memory, all these resources that you actually have at your disposal as a validator, GPUs, etc., can give life to these other mechanisms that end up mattering for what UX can be unlocked. So yeah, super excited.
Cool. And in my perception, and it's why very interesting to combine lensing protocol and infrastructure, because literally we started in 2021. And the initial idea is to make something which could improve UX. So for last 3 years, we made a lot of innovations like multi-call, when in one click you can get a pretty complex position, and you should not really think about all this intermediary stuff. If you really end up with Uniswap and then the rate was different, you can really get stuck. Then we created a pretty cool system when you can easily use a lot of different protocols, which even has no tokens like Convex or some restaking protocols as well. And the next part, what I'm focusing, is called lending infrastructure. Because imagine in more broader way, today we're more focused about end users, and it's a huge part. But if you consider a few different networks, it's all time the timing between them could exist, and sometimes you need resource on any rollup or any other network immediately, and then probably you can deliver it or pay the debt back. So we can start thinking about lending as infrastructure to deliver resources through the Gearbox when they need it. For example, you want to get some token on rollup A, we could credit you and then use the system like Lagrange, deliver this data back to mainnet and say, hey guys, this person credited on this network because we have a latency, we have something asynchronous between things happens in new world. We can simply compute the resource and how much resources like assets or credit were used. And then we can pay the bill or provide some capital somewhere and we can unlock it. So it could create a totally different stuff when lending could focus not only on user solution, but be a part of bigger infrastructure to create a totally new scenarios. I believe you remember some years ago, we talked more about IoT and how blockchains could improve the field. And today we have a pretty interesting solution in DePIN. And just imagine, with so complex infrastructure, we can really add different sources, provide credit, lending for users, for machines, for intent solvers, etc., and deliver the data in asynchronous way. And in this case, I believe both Lagrange and Eigenlayer made a huge job, because this data delivery could really make a pretty interesting stuff. And because we have some timing between networks, you should always take a credit or anything else to get resources faster, maybe than existing solution. It always happened. So I pretty bullish about new infrastructure and how we could implement it and build something new, because there is no way to build existing services what we can get in Web 2. Web 3 is different, and maybe we can find a new UX to create a totally different things in more decentralized way for end users.
No, 100%. I mean, historically, as technology becomes cheaper, easier, and more cost effective to use, right? It's like you end up setting new precedents for how it can be used, what new APIs are offered from both infrastructure perspective, but also product perspective, right? So yeah, we're just seeing that tip of the iceberg for this. But Ismail, if you have any specific comments on that.
No, I think that's very well put. I mean, I think what we've been able to unlock by building on eigenlayers is very singular to the eigenlayer ecosystem. Low cost of capital on our stake that we have for our prover network, and then obviously a fantastic and robust operator base running our infrastructure to be able to guarantee high SLAs of liveness to Gearbox and many of our integration partners. And I think Mikhail has put this very well, that once you start talking about an evolution of the underlying infrastructure, which I think is embodied by great infrastructure partners, low cost of capital, and then increasingly cost-effective forms of compute, which is what we can get with a bunch of the core innovations in zero knowledge that we have access to now, you get to a future where the types of applications you can build are just fundamentally an order of magnitude better, a step function better than were possible before. And I think, it's a real credit to I'd say, application level builders at the forefront, like Mikhail and the Gearbox team, to identify these primitives, embrace these primitives, and then build novel technology on top of them.
Absolutely. Well, this has been super fun, folks. I know we're out of time, but is there anything else, any last words you'd like to say from either side? Mikhail, maybe you want to give a few last words?
Maybe it's just things. So after the Singapore, I spent a week there. I'm pretty bullish about things we can build using new infrastructure. I definitely believe the industry exists as a pendulum. So we move between apps and infra back and forth, back and forth. And now I can see more and more interesting solution time to see. And it's time to rethink how we can utilize the power of amazing stuff we just start learning. And in this case, I expect that maybe in next year, we can really find totally new application, very smart ways to utilize shared security, ZK coprocessor, AI through the AVS, and etc. And I think we should start dreaming about things we can build for end user, because previously we were a little bit lacked with different stuff all time. When you had something to read the gas, you feel yourself like someone who steal money from user pocket because the price was very high. And today we can just unleash our creativity and find the use case of tomorrow. And I think it's very inspiring.
Those are perfect parting words.
Thank you.
Thanks for taking the time, all. And yeah.
Thank you, guys.
Thank you,
Thank you
guys.
so much. Have a nice day. See you.
Okay.
Bye-bye.
Likewise.
See you. Bye-bye.